Welcome to another tutorial on Easy System Designer. This video shows the basic first step in drive sizing, namely the selection and description of the application. You start a new drive sizing. In the upper area, you can select your application and perform a new drive sizing for it. The 5 most recently created sizings are located in the lower section. These are temporarily stored in the browser cache. If the cache is deleted, these projects will no longer be available. A login is required for long-term storage. You can optionally select the unit system. By default, both the metric and imperial unit systems are selected. You can reduce this to your preferred. The first 5 steps of the sizing process are always available and are calculated using the data currently entered. This means that a calculation result for the application is always available. Initially, this is based on preset default values. You must adapt these to your specific application. Various typical applications are divided into groups. The following groups are available: conveying, a belt conveyor, roller conveyor, chain conveyor, and bulk material conveyor. Positioning, a traveling drive, a spindle drive, rack drive, belt drive, an omega belt drive, and 2 crank applications with rotary or translatory speed definition. Under the rotation group, you will find the general rotary drive and a rotary table. For lifting, you will find rope-guided hoists with and without counterweights and an eccentric lift table. For synchronous drives, there is one application with a single roller and one with pinch rolls. Pumps and fans are also in one group. For winding, there is the winder and the unwinder. And then there is another application for importing torque speed values from other calculation or simulation tools. We explain this in another video. Online help is available to help you better understand the application. It opens in another browser tab. Select the rack as an example and click on Continue. When describing the application, the characteristic application data must first be entered. This includes the basic data, in this case, for example, the diameter of the pinion and the mass of the rack. There is also extended data, which is used for a more detailed description. In this case, for example, the angle of inclination or the coefficient of friction of the guide rail. The sketch, tooltips, and online help assist in understanding the application data. When you switch units, the entered value is converted immediately. Enter a value. After a short time, the calculation is performed, and the calculation results are updated in Step 4. There are auxiliary calculators, such as the inertia calculator, to calculate the total inertia from individual elements. There are also auxiliary tables with physical coefficients, which can be selected directly. The auxiliary calculators are explained in another video. Once you have entered the data, click Continue to proceed to the rack movement input. How the Motion Designer works is also explained in another video. In this example, continue with the default values. In Step 4, you will see the determined requirements. These are the physical calculation results in the form of speed, torque, and power based on the application data and movement. This serves as a plausibility check to ensure that the application has been entered correctly and meets your expectations. On the left-hand side, you will find important key data. There is also additional data here. For example, you will find the maximum speed, the maximum torque, or the effective torque of the application. On the right-hand side, you will find diagrams that show the physical requirements on the time axis. The 3 most important ones are directly accessible. A diagram not only shows the progression over time, limit values, or, as in this case, the effective torque are also displayed. The legend contains additional useful values. This means that all important information is directly available. Additional diagrams can be opened here in a dialog box. You can view multiple diagrams. If space is limited, you can reduce the size of the diagrams. With the same scale for all x-axis function, you can read values for several diagrams simultaneously. A zoom function is also available. You have now fully described and checked your application. You can continue with the next step of the drive sizing. Feel free to watch our other videos to get the most out of Easy System Designer.